So I'm going to film another Higgs video. This is HERA 5, Higgs fields Hadron CERN Tetraquarks NONET Meson Electromagnetic force. So I did the research on it September 24th, 2012. Today's October 4th. So this is a continuation from the keywords found in the previous video data. There's HERA 1, 2, 3, 4 before this, and it goes up to 6. So HERA 4 DESY, electromagnetic ionizing radiation, that was the keyword. And here's a picture of the Higgs signature of a Higgs boson from a simulated collision between two protons. It decays almost immediately into two jets of hadrons and two electrons visible as lines. It's an elementary particle. It's bosonic, tentatively observed. A boson consistent with the Higgs boson has been observed, but as of August 2012 has not been conclusively identified as the Higgs boson. Symbol is H0. 22nd September. My thoughts continued. Your data states that the Higgs boson simulated collision between two protons, two jets of hadrons, two electrons as visible lines. The keyword hadron from the CERN's Higgs boson results and bosons. Quotes from Wiki. In particle physics, a hadron is a composite particle made of quarks held together by the strong force as atoms and molecules are held together by the electromagnetic force. Hadrons are categorized into two families: baryons made of 3 quarks and mesons made of 1 quark and 1 antiquark. Other types of hadron may exist, such as tetraquarks, or more generally exotic mesons, and pentaquarks, exotic baryons, but no current evidence conclusively suggests their existence. Examples of bosons include fundamental particles, Higgs boson, and 4 gauge bosons of the Standard Model, and the hypothetical graviton of quantum gravity, composite particles, mesons, stable nuclei of even mass number. Examples: deuterium, helium-4, lead-208, and quasi-particles, Cooper pairs. The bosons differ significantly from a group of subatomic particles known as fermions, and that there is no limit to the number that can occupy the same quantum state. This behavior gives rise, for example, to the remarkable properties of helium-4 when it is cooled to become a superfluid. So September 22nd is my thoughts, and again today I'm filming this October 4th. My thoughts are continued. The hadron equals a composite particle plus quarks plus strong force plus atoms plus molecules plus electromagnetic force. The keywords: baryons, 3 quarks, mesons, 1 quark and 1 antiquark. The tetraquarks, exotic mesons, pentaquarks, exotic baryons theory only. Something to prove: tetraquarks, pentaquarks, etc. So I'm going to Google tetraquark. And this is a quote from Wiki. In particle physics, a tetraquark is a hypothetical meson composed of 4 valence quarks. Now isn't that interesting? Because it says it's composed of 4 valence quarks, and I'm trying to split the neutrino down into 4 quarks. So there we go. Maybe the formula for... so the formula we created for the neutrino to split down into 4 quarks, what if it can create the tetraquark? That'd be cool. In principle, a tetraquark state may be allowed in quantum chromodynamics, the modern theory of strong interactions. However, there has been no confirmed report of a tetraquark state to date. Any established tetraquark state would be an example of an exotic hadron, which lies outside the quark model classification. So my thoughts continued. We need a tetraquark with a neutrino so it can mimic the 4 valence quarks. Add split and spin leptons and fermions into the mixture for fuels, energy, and dark matter. Higgs boson mass particle experiments. So the exotic meson diagram from Wiki. So you got your L, Q, Q, S1, S2. So this is a quote from Wiki, a regular meson made from a quark Q and an antiquark Q, with spins 2 and S1 respectively, and having an overall angular momentum of L. My thoughts: this diagram looks like another one. NONET is covered in several videos from now. See Q and S. So when I mean Q and S, I'm talking about... what am I talking about? Oh, see the Q and S in the diagram. Never mind. See the Q and the S's in the diagram? That's what I'm looking at there. So here it is here. I found the NONET, which is 9 particles, but see how it's got the S's on this side and the Q's on this side? So I'm looking to put the two of those things together for some reason. I don't know. We'll find out, right? So my thoughts continued. I wonder if anyone else has put these two together before. So I'm going to Google NONET Meson. Looking at the Wiki Meson definition keywords, so I read the data and I picked out some of the keywords that stand out. And basically it's based on the WOW videos that I'm working on, the alien radio signal. I got a bunch of keywords from it, and from these keywords I'm using them to find keywords in the Higgs signal to see what we can put together to create a Higgs mass particle. So charged meson decay through other particles to form electrons and neutrinos. Uncharged mesons may decay to photons. So those are the keywords. So we can assume based on this that the CERN Higgs signal has a meson in it that decays into 2 photons. Neutrinos can be used to create supersymmetry because they mimic particles they come into contact or collide with. The electrons can become electromagnetic. So quotes from Wiki, a meson. In particle physics, mesons are hadronic subatomic particles composed of one quark and one antiquark, bound together by the strong interaction. Because mesons are composed of subparticles, they have a physical size with a radius roughly of 1 femtometer, which is about 2/3 the size of a proton or neutron. All mesons are unstable, with the longest lived lasting for only a few hundredths of a microsecond. See, I didn't realize that your particles that you guys are studying don't last very long. So one of the things that I'm trying to do with these videos is come up with a formula so that you can make it last longer so you can study it better. So the charged meson decay, sometimes through intermediate particles, to form electrons and neutrinos. Uncharged mesons may decay to photons. Electromagnetic force. Here's the key to the whole enchilada. When any charged particle moves, it creates a magnetic field around its path of travel. Any charged particle and any movement, the moving charge creates something like a little magnet tunnel around its path of travel, and that field, that magnetic field, moves with the particle constantly surrounding it. I believe this is a quote from a blog, but I'm not sure which blog I got it from, and I kind of lost that. So just so you know, these are not my words, this is from somebody's blog, okay? We usually move electrons to do work, and when we move a lot of them, we create a large magnetic field around the conductor through which the electrons move. The moving electrons are current flow, that is electron current flow or electricity, and if we coil the conductor through which the current is flowing, we can cause the magnetic field around the individual wires to add up and make one bigger field. The bigger field reaches around and the entire coil of wire, and the magnetic lines of force all flow through the center and then out one end around the coil in all directions and then back into the other end. Now this was really interesting to read because it kind of explains how the process is for charging your particles and stuff, and this actually comes up later on in the formulas showing you how to do it. So it was very helpful, whoever wrote this. I tried Googling it and I had it open on my computer, and then my computer shut down on me because it decided to update when I was doing research and I lost it. So I do apologize. Normally I have the source there, but it was so well written that I kept it in the video. Okay, so thank you for watching. I'm going to go on to HERA 6 next. Okay.